Okay, hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8 belongs to 4th semester BSc Physics Honor syllabus CBCS model. This is your lecture number 5. In our last lecture we have been discussed in detail about roots of complex numbers. Last class we have been discussed cube roots of unity, corresponding numericals, and using 𝑭𝒖𝒏𝒄𝒕𝒊𝒐𝒏𝒔 theorem we have been evaluated roots of various equations. In this class we are going to discuss functions of complex variables. Okay, so let's start. So before we have to discuss about functions of complex variables, first we have to remember some useful elementary functions which will be required to find out the functions of complex variables or for different numericals. So elementary functions are e to the power, from the Euler's formula, with these two things we already know, e to the power I theta your cos theta plus I sin theta, e to the power minus I theta is your cos theta minus I sin theta, and cos theta will be equal to e to the I theta plus e to the minus I theta by 2, and sin theta will be equal to e to the I theta minus e to the minus I theta by 2y. These things already we have been discussed. These are called the circular functions. Now consider hyperbolic functions. Cos hx will be e to the x plus e to the minus x by 2, and sin hx will be equal to e to the x minus e to the minus x by 2. So these elementary functions you have to remember. Now, relation between hyperbolic and circular functions. Cos theta, for cos theta e to the power I theta plus e to the minus I theta by 2. Consider theta equal to ix. So cos ix will be equal to e to the I into ix plus e to the minus I into ix by 2. Here I into I will be I square, that is your minus 1, and here I into I will be minus 1, already minus is there, it will be plus. So cos ix will be e to the minus x plus e to the x by 2. So cos ix will be equal to cos hx, because cos hx we know that is your e to the x plus e to the minus x by 2, that means this one. Likewise sin theta will be equal to e to the power I theta minus e to the minus I theta by 2i, we know. If we are going to consider theta equal to ix, similarly we can found, here you can see, we can found sin ix will be equal to I into e to the power x minus e to the minus x by 2. That implies sin ix will be equal to I sin hx, because sin hx we know that e to the power x minus e to the minus x by 2. So instead of this one we can write sin hx. Sin ix will be equal to I sin hx. Likewise we can also found cos ix will be equal to cos x, and sin ix will be I sin x. So here I suggest to all of you that you just remember these functions which are essential to solve the numericals. Now we are going to go for the complex functions of complex variables. The Cartesian form of complex number is like this: z equal to x plus or minus iy, that we know. Hence in general the corresponding complex function, that is your fz, is represented as fz will be equal to uxy plus ivxy. Here u is the function of xy, v also function of xy. The polar form of complex number is z equal to r into e to the plus or minus I theta, what we already discussed in our Euler's formula. Okay, so this is the polar form of a complex number. Hence in general the corresponding complex function f of z is represented as u r theta plus or minus I v theta. Here u r theta, that means u is the function of r theta, v is also the function of r theta. Now we are going to go for the first question, that is your question number 31, because in our last class up to 30 question we have been discussed, up to 30. Okay, so this is your 31. Express fz equal to z square in the form of uxy plus or minus ivxy and ur theta plus or minus I vr theta, that is separating into real and imaginary parts both in Cartesian form and polar form. That means given function is your z square, we have to just write in the form of Cartesian and polar form. How it will be? First we are going to go for the Cartesian form. We have to find out the Cartesian form. Fz, given Fz is your z square, where z is your x plus iy. So Fz will be x plus iy whole square, because given that z square. So if we are going to consider x plus iy square, then it will be x square plus iy square plus 2ixy. Here I square means minus, so x square minus y square plus here I 2xy. So here this term is nothing but uxy, and this term 2xy is called as the vxy. That means for this function fz, the real part is your this one, imaginary part your this one. Uxy will be, or the real part uxy will be x square minus y square. Imaginary part vxy will be equal to 2xy. Okay, same thing it has been written, uxy will be x square minus y square and vxy equal to 2xy. Now we are trying to we are going to evaluate the polar form. In polar form, by Euler's formula, we know that z, complex number, any complex number will be written in this format, r e to the power I theta. The given function is your z square, so we can write z r e to the power I theta whole square. So this will be r square into e to the power 2I theta, r square into e to the power I 2 theta, we can write r square. So by using Euler's formula for this one, we can write cos 2 theta plus I sin 2 theta, because we know that by Euler's formula e to the I theta is your cos theta plus I sin theta. So if theta will be 2 theta, so here cos theta will be cos 2 theta and sin 2 theta. That implies fz will be r square multiplied with this. So r square cos 2 theta plus I r square sin 2 theta. Hence for this function, this will be called as your real part and this will be called as your imaginary part. That means u r theta will be r square cos 2 theta and v r theta is your r square sin 2 theta. Okay. So here the given function fz equal to z square represented in the form of Cartesian format and polar format. Okay. Now we are going to go for next question number 32. Express fz equal to z mod square. The given function is your z mod square in the form of uxy plus or minus I vxy and ur theta plus or minus I vr theta. Here given function fz equal to z mod square, and we know that z mod square is nothing but z into its complex conjugate z bar. But z, we know that x plus iy. First we have to derive for the Cartesian, then we are going to go for the polar. Okay, x plus iy. Therefore fz will be equal to z mod square. That means z mod, we know that x square plus y square root over its square means x square plus y square. That implies fz will be x square plus y square. Here there is no imaginary term, so we can write I into 0. So from this is in the form of uxy we can found. Okay, so here uxy is your x square plus y square and vxy is your 0. Now we are going to go for polar form. Z mod square is your z into its complex conjugate. So in your polar form, z is represented as r e to the I theta into its complex conjugate means r star into e to the minus I theta. R into r star is nothing but r square, and here e to the I theta into e to the minus I theta, that means e to the 0. E to the 0 is your 1. Fz we found r square. This can be written as r square plus I into 0. So here u r theta equal to r square and v r theta equal to 0. So for the polar form, the real part of this polar form is your r square, imaginary part is your 0. That means v r theta is your 0, u r theta equal to r square. Now we are going to go for next question number 33. Express fz equal to e to the power z in the form of uxy plus or minus I vxy and ur theta plus or minus I vr theta. Given function is your e to the power z. So instead of z we can write x plus iy. It can be written as e to the power x into e to the power iy. E to the power x written as such into e to the power iy can be written as x cos y plus I sin y by Euler formula. Just multiply this e to the x with this and this. So it will be e to the x into cos y plus I into e to the x into sin y. So here you can see this is in the form of uxy plus ivxy. So this is in the form of uxy plus ivxy. Here uxy is your e to the x into cos y and vxy is your e to the x into sin y. Polar form of this function, what it will be? E to the z will be equal to e to the power, instead of z we can write r e to the I theta is equal to e to the r into e to the power I theta can be written as cos theta plus I sin theta by Euler's formula. Okay, that implies fz will be equal to e to the r cos theta into e to the power I r sin theta, right? So e to the r cos theta written as such. Here e to the power I r sin theta, you just consider r sin theta is a angle. So by using Euler's formula, what we can write? Cos theta plus I sin theta. So here we consider r sin theta is an angle. So it will be cos r sin theta plus I sin r sin theta. Just multiply this e to the power r cos theta with this and this. E to the power r cos theta into cos r sin theta plus I into e to the r cos theta into sin r sin theta. So here this one is represented by u r theta plus I v r theta. Here u r theta is nothing but this term, that is your e to the power r cos theta into cos r sin theta. V r theta is nothing but this much, e to the power r cos theta into sin r sin theta. Okay. So here one thing I want to share with you, that from polar form or from Cartesian form directly we can jump to the polar form. Here you can see we found here x square minus y square for the question number 31. The Cartesian form is your x square minus y square is your uxy. Here x square minus y square, fz is your x square minus y square plus I into 2xy. So if we are going to substitute here, instead of x r cos theta, so it will be r cos square theta minus r square sin square theta. If I will substitute x will be r cos theta, because we know that the x component in the polar form will be r cos theta and y component will be r sin theta. So by substituting x will be r cos theta, it will be r square cos square theta, and y square will be r square sin square theta, plus I into 2 r cos theta into r sin theta, right? So here you can see this will be r square into cos square theta minus sin square theta plus I into 2 r square, or you can write r square into 2 cos theta into sin theta, right? This one cos square theta minus sin square theta is nothing but cos 2 theta. So we can found from here r square cos 2 theta plus I into r square 2 cos theta into sin theta. It is nothing but sin 2 theta. Here this one r square cos 2 theta plus I r square sin 2 theta, right? Likewise from polar to Cartesian also we can jump, that instead of cos 2 theta we can write cos square theta minus sin square theta, and instead of sin 2 theta we can write here 2 cos theta into sin theta. So if we are going to go with the reverse direction, we can also found this one, right? Similarly for this question 32 number question, here you can see x square y square, we got fz equal to x square plus y square. X square plus y square is nothing but r square. Okay, if I am going to put x equal to r cos theta, it will be r square cos square theta plus y will be nothing but r sin theta, it will be r square sin square theta. So if I will take r square common, then cos square theta plus sin square theta is nothing but r square, what we found in the polar form, r square. So likewise here if I will just put instead of r square will be this much, we can found also this one, right? For this question also you can do by yourself in the same manner. Okay, that means here we found, suppose here you can see that we found e to the power r cos theta cos r sin theta, I e to the power r cos theta into sin r sin theta. So instead of r cos theta, we can substitute x. R sin theta can be substituted by y. So it will be e to the x into cos y, what we found here in the Cartesian format, e to the x into cos y. And if we are going to substitute r cos theta as your x, it will be e to the x into sin r sin theta means y, what we found here, I into e to the x into sin y. So we can jump from here to, from Cartesian to polar, or polar to Cartesian. Right, now we are going to go for the next question, that is your question number 34. Express fz equal to zq in the form of uxy plus or minus ivxy and ur theta plus or minus ivr theta. Given function is your zq. Instead of z, we can write x plus iy whole cube will be equal to, here a plus b whole cube means we can write aq plus 3a square b plus 3ab square plus bq. That means a means x, x cube plus 3x square b plus 3x iy square. Here b means iy, okay, plus b square means bq. That means iy whole cube. X cube, here you can say iq means minus I. So minus I y cube taken over here, and this will be I taken to the initial I 3x square y, 3x square y. Here I square means minus 1. That means minus 3xy square, 3xy square. So here I written the real parts collectively, that is your x cube minus 3xy square, and the imaginary parts are this term and this term. That means I whole into 3x square y minus y cube. That means this will be considered as your uxy, this will be considered as vxy. Considering for the polar form, fz, given fz is your zq, and instead of z we can write r e to the I theta to the power whole cube. This will be written as rq into e to the I 3 theta. That implies fz will be rq. This e to the I 3 theta by Euler's formula can be written as cos 3 theta plus I sin 3 theta. rq, if I am going to multiply rq with this will be rq cos theta plus I rq sin theta. So this will be treated as u r theta, and this will be treated as v r theta. Okay, so this is your polar form of this function, this is your Cartesian form of this function. Similarly, if we are going to substitute, instead of x equal to r cos theta, instead of y will be r sin theta, we can also found this term and this term, or this expression also we can found. You can check by yourself in your rough. Now we are going to move to the next question number 35. Express fz equal to z by, express fz which is given as z by z plus I in the form of uxy plus or minus ivxy, plus or what? Okay, plus or minus ivxy. So instead of z, we can write x plus iy. Here also we can write x plus iy. I is there, plus I, x plus iy, and this can be written as I taken common y plus 1. And we just multiplied x minus I into y plus 1 with numerator and denominator of this term. Okay, so x plus iy into this one, x plus I into y plus y 1 into x minus I into y plus 1. You just multiply these two terms, we can found this one, x square minus ix y plus 1 plus I into yx minus I square y into y plus 1 whole divided by, this is in the form of a plus b into a minus b. That means a square, that means x square minus this square, I square into y plus 1 whole square. I square is your minus 1, already minus will be there, so it will be plus y plus 1 whole square. Okay, so here again you just multiply x with this one, y with this one, and we can found this numerator, that is your x square minus ixy minus ix plus iyx plus y square plus y whole divided by x square plus y plus 1 whole square. As such it has been written, the denominator. Okay, here you can found this is your plus iyx minus ixy got cancel, and we found this your x square plus y square plus y and minus ix whole divided by this one. As such it has been written. So this one can be written segregatively, that x plus y square plus y whole divided by this term minus ix by this one. So this will be your uxy, and this is your imaginary part of this function vxy. Okay, so here the polar form also you can found by yourself. Okay, now we are going to go for next question, that is your 36, number 36. Express fz equal to z plus 1 by z in the form of ur theta plus I vr theta. So here given function is your z plus 1 by z. As we are going to express in the form of polar, then z will be written as r into e to the I theta plus 1 by, here z will be written as r e to the I theta. So here r e to the I theta, and this will be e to the I theta will be moved to the numerator, means e to the minus I theta. E to the I theta by Euler's formula can be written as cos theta plus I sin theta. Here 1 by r written as such. E to the power minus I theta by Euler's formula can be written as cos theta minus I sin theta. Just multiply this r 1 by r with this r with this. So we can found r cos theta, here 1 by r cos theta, 1 by r cos theta. I r sin theta, here minus I 1 by r sin theta, minus I 1 by r sin theta. So this, from these two terms, cos theta taken common into r plus 1 by r, plus from these two terms sin theta, I sin theta taken common into r minus 1 by r. So this one is your ur theta plus vr theta. In this way, fz given function is represented in the form of ur theta plus I vr theta. So here we have to stop our this lecture. In our next lecture, we are going to discuss analyticity and Cauchy-Riemann condition. In this class, we have been discussed in detail about functions of complex variables. Next class, we are going to discuss analyticity and Cauchy-Riemann conditions. So thank you so much for watching this video. Thank you.